Dear colleagues, in the pandemic preceding winter, I was looking through a colorful book by Vladimir Payevsky of the Zoological Institute with a synopsis of the passerine birds family Fringillidae and came upon a similarity in the unusual distribution pattern and taxonomic composition between two pairs of the bird and weevil taxa. These are the endemic Palearctic bird subfamily Fringillidae, true chaffinches, and the predominantly neotropical Euphoniae with 32 species on the one hand, and the two genera of the weevil supertribe Orobitis, Orobitis endemic to the Palearctic region, and the South American Parorobitis with two species described from Brazil and Paraguay, and several undescribed species from Argentina and probably Chile on the other hand. The closest affinity between the taxa distributed in so remote and quite oppositely situated regions is of considerable interest with regard to their faunogenesis, which was noted by Vladimir Payevsky in his book. The two pairs of the vertebrate and invertebrate taxa are isomorphic in sharing not only distributional types, but also taxonomic structure. The both Palearctic taxa Fringillidae and Orobitis are oligotypical, comprising 3 and 2 species respectively, whereas the South American Euphoniae comprise two closely allied medium-sized genera, including 32 species in total, and Parorobitis likely also includes much more species than are known so far. The isomorphism of the two unrelated higher taxa, those of the birds and weevils, may imply very similar, if not common, history of their faunogenesis, although close zoonotic association of the phytophagous Fringillidae and weevils can hardly be imagined. The distribution of the subfamily Fringillidae is shown in Figure 6. The polyzonal common chaffinch Fringilla comprises 18 subspecies in the Western Palearctic, one of them distributed eastward to Transbaikalia and rapidly extending its range still further east. The blue chaffinch Fringilla is endemic to the Canaries, and Fringilla montifringilla, the brambling, has wide boreal Euro-Siberian range. The Euphoniae are distributed from northwestern Mexico in the north to northern Argentina and Uruguay in the south. The weevil genus Orobitis, Figure 7, comprises the Transpalearctic Orobitis cyanea, distributed from the north of the boreal zone to the Mediterranean Europe, and the South Central European Orobitis nigrina, with the distribution almost identical to that of the monotypical Suterin hind genus Euceliodes, with close allies only in the South African fauna. The two described Parorobitis species are distributed in the tropical South America, but there is also an undescribed species in Argentina. Yet the goal of this short communication is not to stimulate a search for the explanation of the unusual distributional pattern of the Orobitidae, which is a good challenge by itself, but to attract attention of the South American colleagues to Parorobitis. First of all, to try finding its host, which are supposed to be in the Violacea, in whose seed capsules Orobitis cyaneva develops. Contrary to the usually non-flying Orobitis, with the vestigial hind wings and subspherical body, Parorobitis has extremely broad body with strongly prominent humeri and most likely flies very well. Its affinity with Orobitis was inferred from a similar structure of the head and legs, which probably operate similarly in the two genera, and thus sharing a bionomics would be a good option. The Violacea are widely represented in South America, and search for Orobitis associated with them might give additional evidence for the affinity between Orobitis and Parorobitis, or rather, for their faithfulness to the host family during a considerable period of their separate evolution in the so different biomes. The host may be identified now by barcoding the content of the proventriculus or the midgut, but the direct evidence, that is, rearing adults from the seed capsules of the Violaceae, would be perfectly convincing. Further speculating at the late autumn weekend night might give expectation of Orobitis in the temperate or cold South American regions, or at considerable elevations in the Andes following the habits of the Palearctic algae. Taking into account its potentially excellent flying capacity, Parorobitis, which is extremely rare in the collections, may be expected living in the tree crowns. Probably using flight intercept or Malay traps could provide material of this interesting group. A pessimistic remark here is that I have not found Parorobitis in the voluminous material fogged by the late Terry Irvin in Peru. Strangely, neither did I find in the terrace material any Panophthalmus of the Suterine Hyete, living in the aerial roots of the Vitaceae and flying probably not worse than Parorobitis. An explanation may be that the adults of these groups are even faster than the toxic fog action and escape before becoming heavily poisoned. It is not also unlikely that Orobitis live in South America on herbaceous viola, as they do in Eurasia, and then may be collected with the flight intercept traps established in the herbage layer. In the highlands, they may look less picturesque than the known Parorobitis species and be neglected in the material among the small wingless Phanerognatous weevils. I have found a wingless scleropterine of the Suterine Hyete in the mix of a small liter molitines sifted by Alex Smetana at 4,000 meters above sea level in Nepal. Discovery of such weevils in South America would be a good contribution to the systematics of the Canaderini sensulato, because no specialized alpine genus or even species of Suterine Hyete is known in the New World, whereas in Eurasia, they constitute a noticeable part of the alpine faunas. And the Orobitis probably are closest to the latter tribe in the whole subfamily. I'm not spelling here the acknowledgements and the references to the paper by Maevsky and the paper on the Orobitis and its American allies. Thank you very much for your attention.